Good afternoon, everyone. Welcome to my class. So, how are you today? I hope you are all feeling good. So today, we are going to discuss about earthquake, waves, and the earth interior. So this is our week 3 and second quarter. Now, this is how our earth interior look like. So this is how the earth is divided. So first we have the crust, which is the outer covering. Then you have the mantle, the outer core, and the inner core. Okay. But first, we have to know our learning objectives for this lesson. So first is to identify the Earth's layer. Create a model that describes the Earth's layer. State the different kinds of body waves. Describe how primary and secondary waves moves when earthquake occurs. And explain how earthquake waves provide information about the Earth, interior of the Earth. Okay. So, we have to know first that the Earth is composed of 4 layers. So namely, we have the crust, the mantle, the inner core, and the outer core. So first we have to discuss all about the crust. So the crust is the outermost layer, which is much more familiar to us and was comprehensively studied by our scientists. But how about the mantle and the core? But class, we have also to remember that we are in the outermost layer of the earth. So the surface or the area where we are standing, that is the part of the crust of the earth's layer. Okay. Now, but how about the mantle and the core? Has anybody been there and collected data about it? The answer is no. Humans have been to the moon, but nobody had gone deep as the mantle. Okay, so how do you think that the earth layers were discovered and illustrated when nobody's in it? We often consider earthquakes as a problem, a scary disaster we are always afraid of. But did you know that it had also helped our scientists discover what's deep in the earth? Now, let us find out as we go through with our discussion. So, please be ready. Now, what is inside the earth? We frequently believe in the earthquakes as something devastating, and the idea is apparent. Earthquakes help scientists to discover what is inside the earth and how. As you know by now, when a fault abruptly shifts, an earthquake is generated. So we discussed that previously. So the shaking rises from the focus and radiates out. That is why we experience an earthquake. The moment the ground is shaking, then automatically we can say, oh, there is an earthquake, right? Now, the earth crust is a thin shell on the outer side of the earth, accounting for less than 1% of the earth's volume. It is the top component of lithosphere, a division of earth's layers that includes then crust and the upper part of the mantle. So the lithosphere is broken into tectonic plates, okay? The lithosphere is broken into tectonic plates that move, allowing heat to escape from the interior of the earth into the space. Okay, so this is where the crust of the Earth is being described in this picture. Okay? Now, how about the Earth's mantle? So the Earth's mantle, which is about 2,890 kilometers thick. So if you're going to imagine what is 2,890 kilometers, so if you know how to estimate 1 kilometer, that is how far. So now if you're going to think of 2,800 kilometer thick, no? So that is where your mantle is. That is the thickness of all the layers. So imagine the Earth's mantle is the thickness of all the layers of the Earth because pressure increases as you go deeper into the Earth. So mantle rocks are denser than the cracks of the rocks. Again, the mantle rocks are denser than of the crust rocks. Okay. Okay, now we will move on to the lower mantle. Okay, so where can you find the lower mantle? So it is in the middle layer of the Earth layer. Then it is very thick in layer. Molten rocks are fluid and moving in a circular motion called the convection current. Okay, so if you try to look at the picture, then this is where can be found out. Then, you have here the Earth's outer core. So, it is a fluid layer about 2,400 kilometers thick and composed of mostly iron and nickel. So, that lies above the Earth's solid inner core. And below it's a mantle. So, its outer boundary lies 2,890 kilometers beneath the Earth's surface. So it is also far from the Earth's surface. So if you are going to think of the mantle, that already measures or 2,800 kilometers. So if you're going to estimate that, if you're going to try to figure it out, then it is really thick. So mostly it is made up of iron and nickel that lies above the Earth's solid inner core and below its mantle. Its outer boundary lies 2,800 kilometers and beneath the Earth's surface. Okay? So try to look at the diagram as it is illustrated here, the outer core. So where it is located. So it is above the mantle and it is also below the inner core. So I hope you follow. Okay, so we'll move on to the next slide. Okay, now let's move on to the Earth's inner core. Okay, so as you can see in the picture, so how it describes. So the inner core is the innermost geologic layer of the Earth. It is primarily a solid ball with a radius of about 1,220 kilometers, which is about 20% of the Earth's radius or 70% of the Moon's radius. Okay? So, if you know that the layers of the Earth have different physical and chemical characteristics. So it is impossible to drill a hole from one side of the Earth all the way to the other side. And no one has seen the Earth's interior, if you know that. So how did we get this information? So again, seismologists use earthquake to be able to see inside the Earth. So when an earthquake occurs, seismic energy radiates. So from the focus as the seismic waves, so those that pass through the Earth's interior are called the body of waves. So it is hot, very hot inside, no? So the inner core, this is the hottest portion of the Earth's layer. Now, we have here the types of body waves. Body waves. Those are body waves. Okay. So we have here the primary waves and secondary waves. Now, P waves, or this is the primary waves. Okay, so class, try to remember that the P wave stands for our primary waves. So these are the fastest type of body wave. So they arrive first as at a seismograph station and are recorded on a seismogram. So the P waves are the longitudinal waves because they compress and expand like a spring in the direction that the waves travel. Because all of material can be compressed and expanded. So, P waves can pass through the solid and the liquid layers of the Earth's interior. Now, this is the diagram or the illustration how it is being uh, described or it is being explained, no? When it comes to their movement. So that is why our scientists know what is inside in the Earth's layer. That is because of the body waves, okay? So that is when an earthquake occurs, then you have the seismic energy radiates from the focus as a seismic waves. And those that pass through the Earth's interior, those are the body waves. So this is the direction when there is a wave propagation. So compression on the left side and expansion. So as it is said that all of material can be compressed and expanded. So again, the P wave can pass through the solid and the liquid layers of the Earth's interior. So kaya alam natin kung gaano kalakas yung earthquake because of this process. Okay. So this S wave or the secondary waves travel lower than the P waves. So they arrive at seismograph stations after P waves. So mas nauuna si P waves. And then they are recorded secondly on seismograms. So the S waves are transverse waves because they rise and fall perpendicular to the direction traveled by the waves that form in a rope that is shaken up and down. So, S waves can only pass through the solid layers of the Earth's interior. Unlike the P waves, no, again, unlike the P waves, it can pass through the solid and liquid layers of the Earth's interior. Okay? So this is how the secondary waves looks like. So you have here the crest and you have the throat. This is now the movement of the waves, the body waves. And then it shows also the direction of the wave propagation. So this is how the wave is being propagated. And if there is an earthquake, then they can trace, no, as to where it passes through. Kaya nalalaman natin kung saan nagsisimula yung earthquake and up to saan sila nakarating. That is because of this study or because of the use of this seismograph. And of course, it is being recorded on a seismogram. Okay. Now, we have here the diagram or illustration of seismic wave. So you have here the undisturbed material. Okay, it is understood no, that this is not being bothered by any waves. So look how it looks like compared to the primary wave. So there is already movement. And also the secondary wave, as you can see the secondary wave, that there is a crest and there is a trough. So you also have to measure the wavelength. And then for the secondary wave, really wave and the log wave. Okay. So try to take a look on the seismic wave. And also, you have to take note that layers of the earth have different densities and elastic properties. Right? So, di ba magkaiba yung densities ng crust, mantle, the inner, and the outer? So, the speed and direction of the body waves also change as they pass through the different layers of the earth. So, instead of traveling in a straight line, the waves also are bent. Kaya nakikita nyo in our primary wave that there is also a bend of waves. Kaya sabi ko, merong crest at saka merong trough. So that nakikita nyo also the distance na the wavelength kung gaano kahaba. And then also, sa crest kung gaano naman kataas yung wave. Okay. So, one body waves make it through the Earth's interior, and they are also detected by seismographs when they reach in the surface. So again, it is through the seismographs, that is why we can trace the movement of the waves beneath the Earth's surface. Okay. So, it is the seismologists that notice the P waves pass from the crust into the mantle as their speed increases. So, the speed change marks a physical boundary that is called the discontinuity caused by the density across the boundary. Okay. Now, okay, this is how seismic waves travel through the Earth's interior. So, if you are going to imagine or try to figure it out that this is the Earth's interior. Ito sa center, ito na yung core, then you have the inner core, then the outer core, the mantle, and the crust. So, this is how the seismic waves travel through. Nakikita nyo naman ang mga arrows. So, if you try to follow the direction, you have here the P wave. So, nakikita nyo kung saan yung P waves and the S waves. So, the P waves, it is the color black. So, where did they pass? And also the red one, that is the S wave. So, for you to be guided, then try to use observe the color where they are going through. So that is how they are being distributed, no? Or that is how the seismic wave travel inside the Earth's, or in the Earth's interior. Okay. So as you can see, diba I told you earlier that only P waves can travel or can pass through. So if you're going to look at, try to look at the red one. So the red one, this is the S wave. So as you can observe, as you can notice that the S wave or the red color cannot pass through the center, right? Okay. So unlike the P wave, so they can just easily pass through. Diba? So did you notice that the P waves can pass through the solid and the liquid layer? So if you're going to try to look at the color. So the black one that represents the P waves, okay? So the black one that represents the P wave and the red one that represents the S wave. So if you're going to look at the red color, then it then pass no, at the center. So meaning to say, it is only the P waves that can pass through the solid and the liquid layers of the Earth. Okay. We'll now move on to the next. So, it is this seismologists notice that P waves pass from the crust into the mantle. Yes. The speed change marks a physical boundary called discontinuity caused by density across the boundary. Then you have here the MOHO, which is stands for the Mohorobic discontinuity, is the discontinuity between the crust and the mantle. So this is where the MOHO is. It is just near the crust and it is above the upper mantle. Okay. Now you can see where is the inner core, the liquid and solid boundary where the S wave cannot pass through. While the P wave, of course, whether it is a solid or a liquid, it can pass through. Okay, so that is how the seismic wave works on the Earth's interior. Now, do you think our country had ever experienced tsunami? The answer is yes. As recorded by PhilBox, the Philippine Institute of Volcanology and Seismology, in November 1994, a 7.1 magnitude earthquake produced a tsunami that is caused 39 people to be drowned in Mindoro. Also, a magnitude of 8.1 earthquake along the Cotabato Trends that produced also a massive tsunami waves as high as 9 meters in Moro Gulf. So that was around 8,000 people were killed or missing, and it is known as the most disastrous tsunami to hit the Philippines in the last 4 decades. So I think we are not also familiar since that happened long years before. So only those people who usually have witnessed, then they can also remember that. But now, as what we have discussed, that Philippines experiencing tsunami also. So together, let's explore and learn about tsunami and how it is generated. So what happened? So earthquake produced tsunami, okay? If a fault suddenly moves on ground, you can get an earthquake. So however, if a fault suddenly moves in or near a body of water, you may get a tsunami. So in addition to the earthquake, so moreover, earthquake waves give data about the interior of the earth through term the seismic waves. So seismic waves move within the body of the earth at a specific depth. That waves are reflected and refracted. So that is the bent, no? So that indicates the earth must be layered. So that is why scientists can tell us the different layers of the earth. Okay, so this is what could happen if there is a tsunami. Okay, so this is the behavior or the result if there is a tsunami. So if you can see that there is a beach, my beach, no, and then people are running around just to escape the The water. Okay. So trying to save yourself when there is a big water coming. Okay. So this is how tsunami looks like. For those who do not have yet the idea of how tsunami is, then it is most likely illustrated in this way. The body of water. So look at the caricature. The body of water as if the water would want to eat the man and the sun. Yes, of course, because tsunami can kill a lot of people. Now, have you heard about tsunami? Probably yes. So tsunami could be one of the most disastrous phenomena that has been part of the nature's mechanism. So it is very deadly that it had killed thousands of lives in a matter of hours in the different parts of the world, like Japan. Of course, Japan can always experience tsunami. Japan, Indonesia, Thailand, and many other countries. So let's have to be safe. So do you think our country had ever experienced tsunami? Of course, the answer is yes. So we have discussed that earlier, right? So if we can experience tsunami, then this is really disastrous. And it can cause a lot of damage and even life, and putting life in danger and even to death. Okay. So here, tsunami is a Japanese word. Oh, tsunami is a Japanese word pronounced as tsunami. Tsunami, which means wave in the harbor. Sometimes it is misnamed as tidal waves. So it is caused again by an earthquake and the other movements on the ocean floor. So earthquake happens on the ocean floor. So it travels at speed up to 600 miles per hour. So 600 miles, that's really fast. Tsunami traveling in deep water in open ocean causes no damage and are hardly noticeable. Tsunami traveling in shallow water can batter coastlines with waves as high as 100 feet, causing considerable damage. So good if tsunami occurs in the no in an open ocean far away from the harbor because it is unnoticeable and of course can cause no damage. But if it happens in a shallow water or near the coastlines, then it can create waves as high as 100 feet. So a lot of people could possibly brought to death. So how is tsunami formed? Tsunami form. Okay. Faults are seen not solely until land. Okay? Hindi lang nangyayari ang fault sa land, but even under the ocean, in the surface of the ocean, faults is present. So when a fault at the ground of the ocean swiftly moves, then the water over it can be stirred. And an abrupt force from the underwater fault can create a wave, and now that is named as tsunami. Okay. I know you are very familiar with the word tsunami. Okay. So unlike a wave that is produced by the wind, a tsunami is extremely strong. Okay. So this is how you are going to differentiate between a wave and a tsunami. A wave is caused or produced by the wind, but tsunami is caused by extremely strong wind waves are simply sea surface waves. Okay. So while a tsunami includes the complete underground force, the ocean, from the seafloor of the surface. So this is how you're going to differentiate a wave and a tsunami. Okay? A wave that is produced by the wind, a tsunami is extremely strong. So wind waves are simply sea surface waves. Wind waves, yung may bagyo, that is what we call a strong waves caused by a storm or strong weather or bad weather. While a tsunami includes a complete underground force of the ocean from the seafloor to the surface. So again, a fault line cannot only happen in a in a land, but also under the ocean or from the seafloor of the surface. Okay, this is now the mechanism of a tsunami. So try to look at the diagram. You have here the subducting plate. So there is earthquake there. So if you look at this illustration, then where the earthquake occurs, it is here. And then try to look at this subducting plate. So yung isang plate medyo bumaba, then yung isang plate, it rises up. So the moment yung isang plate, it rises up, so what happened to the water? The water is being pushed up. So try to follow the arrows, the direction of the arrows. Then, as it pushed up, waves spread out. And then, waves slowly and gain weight, and it will travel saan? Of course, patungo na doon sa harbor or patungo na doon sa ground. So, tsunami now hits the surface of the earth. Okay, so tectonic plates shift causing an earthquake and displacing the water. So the waves can travel unnoticed at high speed across the ocean. So as they approach the shore, they slow down and gain in height. So kaya dumami na yung water. Kaya, as expected, medyo mababa lang yung water sa shore, but when there is an approaching tsunami, then it rises up. So the highest tsunami waves can be up to 30 meters to 100 feet high. So medyo malayo-layo din. And mataas din. Okay? So how are earthquakes associated with tsunamis? If the earthquake occurs in the ocean, it can push up powerful waves known as the tsunamis. Though the sudden upward or downward movement of the seafloor during an earthquake creates a large tsunami waves. So similar to a child splashing in the bathtub. So if you try to figure out, usually if you are taking a bath, then you are in the bathtub or in the basin, you usually splash the water. So what happened? So earthquakes can also trigger tsunamis by unleashing underwater landslide, which also displays huge amount of seawater. Okay. So know the tsunami natural warning signs. So try also to be resilient when hazard came across. No, you can when there is a news about this, then or just try to be alarmed if you happen to hear this sign that there is a coming tsunami. So first is you have to feel a strong earthquake that makes it hard to stand up or last for more than a minute. So again, it is a long earthquake because it lasted for a minute. So it is a long or strong. Then see a sudden rise or fall in the sea level. So if you are living in the coastal area, then try to notice this. So please be vigilant. Then hear loud or strange noises from the sea such as a roaring sound. So if you can see an unusual sound in your environment or in your surroundings, then the weather is not good and there is an earthquake, then try to look outside. Then try to observe if there is a possible of tsunami, of the coming of a tsunami. Okay. So not all fault movement underneath the sea will create a tsunami. Maybe pag weak lang, then you cannot experience tsunami. So these faults that move during a horizontal direction or sideways will not result into a tsunami. Tsunami can only be experienced if the movement of the surface is uh, the other wall is subducted and the other is on top. So the fault has got to move within the vertical sense. So within the activity, a sudden upward thrust triggered the wave. It should also be noted that not all earthquakes generate tsunamis, okay? So again, class, not all earthquakes generate tsunamis. It depends upon the movement of the fault. Usually, it takes an earthquake with a rate magnitude exceeding 7.5 to produce a destructive tsunamis, okay? So individuals usually use the word tidal waves if they discuss tsunamis. That's not correct. So tsunamis are thanks to the sudden upward or downward action of rocks, accompanying a fault at the seafloor. So tsunamis aren't related to tides, yes, which are deterred with the effect of gravity. The concept of tsunami is extremely powerful is that every wave includes the whole bottom of the ocean, not the salt water on the surface. And why does a tsunami grow to such elevated heights when it approaches to the coast? The wave is long about 100 kilometers approximately. When the front end reaches the shore, it slows down. So that is the reason. When it slows down, then there is a rising of the water. Okay, so but the tail end keeps on coming at a high speed. Okay, so naiipon yung tubig doon sa shore. So therefore, the water piles up and builds to serious heights, smashing everything in its path. So sino yung mahuhuli ng tsunami? Then there is a possibility na madadala talaga sila. Then it can brought them to death. Okay, so try to look at this picture. This simply illustrates when there is a tsunami. Okay. So tsunamis are emergencies that endanger shores and seasides everywhere the world. From investigation of experts and archival sources, we understand now that tsunamis are the worldwide happening. They are plausible altogether of the world's oceans and seas, including the Mediterranean. So the Atlantic, the Indian, and the Pacific, and even in large lakes where they'll be caused by landslides. So the incidence and pattern of tsunamis formation seems to be correlated to the amount of every area of the planet and also the pattern and extent of small to very large damaging tsunami occurrences. So tsunamis can only occur in coastal regions and islands are the most targets, okay? So, wala namang nangyayaring tsunami sa land. Of course, it is really in the water. So, class, I hope you enjoyed our topic for today and it brought you a knowledge on tsunami or earthquake. That earthquake can produce tsunami. Okay? So, thank you and have a wonderful day ahead of you. So, see you next meeting. Stay tuned. Bye bye.